This is chapter 1, reflection of light at curved surfaces. Reflection of light takes place on the mirrors. Let's see. Mirror is an optically opaque material which forms images by the phenomena of reflection. When light ray incident on the mirror, it comes back in the same medium. This is known as reflection. So, for studying reflection of light, you should know what is reflection, where it is taking place. So, based on which the mirrors are classified into three types. They are plane mirrors, concave mirror and convex mirror. What are the images formed by plane mirror? So, plane mirror forms certain images, convex and concave. So, images formed by plane mirror are curvature and it appears lateral inversion. And concave mirror is also called convergent mirror. It forms virtual and real images. Concave mirror forms virtual, what we see, and real images. Real images are formed by concave mirror, which is also known as convergent mirror. Convergent means coming together. Okay. Divergent means apart from. So light rays are coming together and meeting at a point. And whereas divergent means they are splitting apart. It also forms erect and inverted images. So concave mirror forms what types of images? Virtual, real images, and also forms what type of images? Erected and inverted. Erected means straight and inverted means upward and downward. Erect and inverted, upward, downward means straight. As we are standing, we can see a straight image, and it also forms inverted images also formed by the concave mirror, that is opposite or ulta images. The convex mirror diverges the light rays. It forms virtual diminished images, and whereas convex mirror forms only virtual, which are diminished images. In mirrors, the angle of incident is equal to the angle of reflection. This is the first law of reflection of lights. Always you have to remember the light coming. See here, you can see in this image, the angle of incidence is equal to the angle of reflection, and this is the plane of medium. This one, plane of median, and this point is called the point of incidence, and at which angle they are meeting known as angle of incidence. And both, and here we should have to draw up a dotted line which is a normal. We will call that is a normal light ray. In mirror, the angle of incidence is equal to angle of reflection. According to Fermat's principle, light selects the path which takes the least time to travel. So which path is selected by the light? Which takes the least time, the less time. So that's why we call it as angle of incident ray is equal to the angle of reflection. And what is divergent, convergent? See here, these are converging. The heads of these, see here, they are converging together. And here, reflection of light by spherical mirrors. The first law of reflection tells us a light ray incident at an angle which is normal at a point of incident will get reflected, making equal angle with the normal. So with normal, I said no dotted line we have to draw in the middle, that is called the normal, and it forms a angle with the incident light and a normal. And this law is true for all surfaces, any surfaces, be it a plane surface or a curved one. This principle applies, which makes an angle with the incident and the normal. The important words here, the angle made with the normal at the point of incidence. If for any surface one can decide the normal and find the incident angle. It is possible to deduce the angle made by the reflection ray. It is very easy to find a normal at any point on the plane surface, but for a curved or uneven surface it is not straightforward. So it is easy in a plane surface, but not whereas on a curved, that is convex or a concave. So this is the image. This is a plane surface. You can see here this paper is a plane surface. and we can find a normal. See the middle point, and this is the angle of incident, a ray of incident and the ray of reflection, and this angle between normal and the incident light is called the angle of incidence, and this from normal to and the reflected ray is called the angle of reflection, and they all meet at a point. This is known as point of incidence, and same axis, they are meeting on a same plane. Plane is also same at a same point at an angle, at an same angle of the axis. Axis also the same. See here, these are the convergent lenses. These are the divergent lenses which diverge the light. These converge the light rays. Let's see laws of reflection. The light ray is incident on a plane mirror and is reflected via another path as shown in the figure. See here. The point where the light intersects the surface of the mirror is called the point of incidence. This is the surface. This is the surface and this is the surface. Mirror. Okay, mirror surface. So what happens? It is called the point at which the angle of incident light and the normal is known as point of incidence. The line drawn the point of incidence with a perpendicular to the mirror is called the normal. Perpendicular there or not, this is a vertical line and the surface is in a horizontal position. So it becomes the perpendicular to the mirror and is called the normal line. The angle formed by the incident ray and the normal, this angle is called the angle of incidence, where they are incidenting or at which point they are meeting, known as incidence. The angle sustained by the normal and the reflected ray is called as angle of reflection, and this angle, this square box, this blue color, this is angle of incidence, reflection. Here they have written, okay, and this we don't draw it as a dotted line. See, all the normal line is dotted, is drawn as a dotted line. This is an imaginary line. Okay, this we can see, but this we will draw because this we can't see. We live in a three-dimensional space, but we experience some activities in two-dimensional space. This two-dimensional space is called plane. The law of reflection states that, first law, the angle of incidence is equal to the angle of reflection, I is equal to R. Second law, the incident ray, reflected ray and the normal at the point of incidence are in the same plane. They are on the same plane. It is not, the incident ray is not here and the reflected ray is here. They are on the same plane, okay, on the same axis. This is called the plane of incidence, at where they are incidenting together is known as plane of incidence. See, this is the reflection, how the reflection takes place. This is the surface, plane surface, and this how the we just see the angle of incidence and the angle of reflection, wherever it may be. Here also. So what are the terms used? Let's see this. Pole is a midpoint. See, this is a convex mirror. It's a spherical mirror. It is a small section of the spherical mirror. From this side, this dark area, dark line there, no? This is the convex mirror from here. And the gray area is, and they have shaded inside. So this becomes the convex mirror. Whereas, so the reflection takes place here at the darker side. Darker marking is there, no? This side. Reflection takes place here. Incident light. If the incident light are just coming here, they will just diverge. Okay. And whereas in concave, the gray part is they have drawn outside the circle. So the reflecting rays, the incident light, they will converge. So concave mirror is also known as convergent mirror. Okay. And this is a pole. See, the if we are taking this part of the mirror, of a spherical mirror, we are taking only this part. Okay. This see the distance between from A to P and B to P. This is the midpoint, and this is equal to the center of the sphere or a spherical mirror. So this becomes the midpoint of the spherical mirror. It's a point where the principal axis meets the mirror. It's a principal axis. This line, horizontal line, called the principal axis, which extends beyond on both the sides. Okay, meets the mirror. What is center of curvature? This is center of curvature. It is the center of the sphere of which the mirror is a small section. This is a see, this center of curvature of which the mirror, only a small section is there. No, this is here, the mirror is a small section. Focus. When parallel rays are incident on the mirror, the reflected ray converge to or diverge from a point. This point is called the focus. See here, if the rays are falling on the convex mirror, what they will do? Convex mirror is diverging. So at point they are diverging the rays, the reflected rays is called the focus. At which point they are diverging. And whereas in a concave mirror they are converged. At which point? If the rays are falling here, from here, and they will just meet in between P and C, center of curvature, and the pole. Here becomes the focus. If they are meeting here, all are converging here, say this point becomes the F, focus. Radius of curvature. What is radius of curvature? The distance between P and C, pole and the center of curvature. This distance, whether for a convex or a concave, this distance is called the radius of the curvature. It is the radius of the sphere of which the mirror is a small section. Small section we are calling these mirror we are calling it as a small sections. Focal length. What is focal length? Focus over, where we can see a divergent light reflected rays and a converged reflected rays. Now we know where is the focus or a focal point. Now what is focal length? Focal length is the distance between the pole and the principal focus. Also it's half the radius of the curvature. Why we are calling also it's half the radius of the curvature? Radius of the curvature is this. This is half. So we are calling a half of the radius of the curvature. And the length is the distance between the pole and the half, means only we are taking this, not the whole thing. So that's why we call that also it's half the radius of the curvature. Focal length is the distance between the pole and the principal focus. Distance between the P and the principal focus. Here, if they are meeting here, say here, sorry here, if the here, anywhere, or for a concave mirror if they are here. So the distance, how much distance? If the focus is here, so how much distance? The distance. And if when the principal axis extends beyond, if we are taking a object, let's say on the center of curvature, FO object, and the image formed here, how much distance it has, at what distance it has formed the image of the object. So that becomes the focal length. Principal axis. The principal axis is the line passing through the center of the curvature and the pole. This line which is passing through the pole and the center of the curvature of the spherical mirror. It extends infinitely on both the sides. Infinitely, so that is called the object distance. The distance of the object from the pole is called the object distance from the pole, where we are placing the object, whether we are placing here, or beyond the center of curvature, or beyond the anywhere. We are how much far or from nearer to the pole, here or here, anywhere. So that becomes the distance of the object where we are placing, and where the image is forming, image distance. The distance of the image from the pole is called the image distance. See, here is the pole. Here we are putting any object. Here is the pole. if we are putting here any, wherever we want to put the object, and where it is forming the image, the distance, how it is forming, the distance of the image from pole, from P, it is measured and it is calculated. Magnification, it is defined as the ratio of the image height to the object. The image is bigger than the object. Alternatively, it is the ratio of image distance to the object distance, and also the distance also, height and distance, and also the nature also. How do you get a virtual image using a concave mirror? Now we are using a concave mirror. So the incident light should be from here, and if it was a convex mirror, the line would we have to draw from here. Now this is for a concave mirror. When the object is placed between focus and pole, this is P. Here this is P, focal and pole, between them, focus and P. Then principal ray are drawn through the object. The first ray is drawn through the center of the curvature and the second ray is incident parallel. First ray, see, first ray is drawn through the center of curvature, is drawn through the center of the curvature. See how the first ray is drawn to the center of the curvature, and the second ray is incident parallel. The second ray, this one, let's see, this one is parallel to the axis, this one, to the principal axis, which passes through the focus after reflection, which passes through the focus after reflection. After reflection, this is passing through, and the first ray is just reflecting, see, and the second one is just passes through the focus after reflection. Both the reflected rays, when produced further, does not meet at a point. So both the reflected ray are produced backward beyond the mirror, so as to meet at a point. At a point we get an image which cannot be obtained on a screen. This image is virtual, erect and enlarged. So what we have to do, we have to form a virtual image by using what? Concave mirror. So the image formed here, see, the image is formed, how it is erect, it is straight, and virtual means it is beyond, it is beyond. At a point we get image which cannot be obtained on the screen, which cannot be obtained on the screen. That's why we are calling it as a virtual, not, it is not a real image. If it is a real image, we would have get here. So it is a virtual, erect and enlarged. See, enlarged or not, bigger than the object, the image is bigger. This tells the this is how we can form an image, virtual image, by using